All right, on day 2, we're going to do a couple things the same as what we just did. We're still going to talk about sine, cosine, tangent, cosecant, secant, cotangent, but they're going to be a little bit different types of problems. First thing I'm going to go through again with you guys. Yesterday we talked about the Pythagorean theorem. There was a couple other types of triangles that you guys had back in the day of geometry. What kind of triangle is that? A 30, 60, 90. And what kind of triangle is this one? A 45, 45, 90. What's so special about a 45, 45, 90? Huh?
It's an equilateral.
Not equilateral. Equilateral would be all sides the same.
Okay, the other one, isosceles.
Good. Okay. Now, in a 45, 45, 90, just so that you guys know what each of these things are, if these are 1 right here, then this is the square root of 2. And the reason how that works is, if you were to actually use the Pythagorean theorem and actually go 1 squared plus 1 squared is 2, and then square it, you get the square root of 2. That was kind of the little trick last year. And I don't know if you guys ever caught that with your geometry class, where if they gave you this is x and this is x, well then this is x times root 2. That was that kind of trick last year. Okay? Then, when it came to the 30, 60, 90, the short side was the one that it was all based on. I don't know if you guys ever caught that, but if the short side was 1, for instance, then the hypotenuse was always twice as long. What's 2 times 1? 2. And then the medium side, or the long leg, as some people called it, was the short side times by root 3. So this is the square root of 3. A couple of the problems today, they're going to give you either a 30, 60, 90 or a 45, 45, 90, and then ask you to come up with those ratios that we did yesterday based on those numbers. Okay, that's what they're going to ask you to do. Bless you. On page 463, on the bottom of that page, there is a chart. That chart might be beneficial for you in your notes. Okay, that chart that's on the bottom of page 463 talks about the 30, 60, 90 and the 45, 45, 90 and the 6 different trig ratios. If you're interested in that, that's something that might go in, that you might want to put in your notes. However, when I'm looking at it, as long as I have those numbers, I can make all 6 of them based off just those numbers without writing the chart. Okay? So again, that chart's on 463. So here's what it's going to ask you to do. It's going to say something like this, or it's going to give you a triangle, and it's going to say find this if that's 30 and that's 12. Now, what we cannot use right now is we cannot use Pythagorean theorem because of the fact that we don't know 2 of the sides. We only know 1. But what we do have is we have a 30, 60, 90 triangle, correct?
Mm-hmm.
Okay. So, a couple different ways of dealing with this particular concept. This one's the hypotenuse. Why is the 12 the hypotenuse? It's the longest side. Good. And then this one would be the adjacent side. Why is that the adjacent and not the opposite? It's next to it. An opposite is across. Right. So which one of the trig ratios yesterday dealt with adjacent and hypotenuse? Cosine. The cosine is equal to adjacent over hypotenuse. So, for this particular thing, the adjacent side was x, and the hypotenuse was 12. Now, the way that this is used, just so that you guys know, the cosine of 30, and this is where that chart comes into play. On the back side, or on page 463, the cosine of 30, if you look at the 30-degree row and go over to cosine. Hunter, what number does it give you? The cosine of 30. The square root of 3 over 2. Okay? So, what I'm doing, just so that you guys know, the chart that's on page 463, I asked Hunter to give me the cosine of 30. So he went to the 30 and over to the cosine, and that's how that root 3 over 2 number came about. Okay? Now, why are we using cosine? Because, as we said, it's adjacent over hypotenuse. If it would have been something else, then I would have picked a different number or a different ratio. Now, how do you solve something like this? Cross multiply. All right. So if I cross multiply, what's 2 times x? And when I multiply these two together, one's inside the house and one's outside the house. 12 root 3. Good. Now keep going. Divide by 2. And when you divide that, it's only outside numbers. 6 root 3. And you just found x.
Where did you get
Okay? Now, just so in case you're wondering, and again, I got it from the chart, but this is what we consider, have you ever heard of similar triangles before? Or similar shapes before? Okay, when we said the cosine ratio, cosine from this angle down here was the adjacent over the hypotenuse. That's where the root 3 over 2 came from, just so that you know that. Okay? Give me that one. Okay. What trig ratio are we demonstrating with these two? Same one? Okay. So, if we're doing cosine, the adjacent side is which one? X. And the hypotenuse is 8. Then if we look at a normal 30, 60, 90 triangle, where that's 1, that's root 3, and that's 2, if I'm in the same positions, adjacent is root 3 over the hypotenuse, which is 2. Bless you. Now how do I solve? Squared. 2x equals 8 root 3. Divide by 2. And x equals 4 root 3. There may be a pattern with that. Okay? So, just so that you guys are aware of it, bless you for the cubed. Okay? That's the first type of question that you're going to see. Make sure you figure out what ratio it's matching. Also, make sure you know what triangle it's matching. We're matching the 30, 60, 90. We're not matching the 45, 45, 90. Okay? Are you comfortable with those? You only got a couple of those. Okay. Now, here comes the big ones. It's going to give you big A, big C, big B, little a, little b, little c. It's going to give you this is 15. It's going to give you this is 28. It's going to give you this is a box. And here's what the directions are going to say. The directions are going to say solve triangle ABC. If I am a triangle, how many parts does a triangle have? Equals. Sorry. How many parts does a triangle have? 6. 3 sides, 3 angles. Right? That's what it has. So here's what I'm going to do. I'm going to list them all out. So there's big A is an angle, big B is an angle, big C is an angle. Little a is a side, little b is a side, and little c is a side. Which ones did they give you? How big is little b? What else did they give you? Big A. 28 degrees. Big C is 90. Awesome. So now, let's find the other three parts. That's what you're going to have to do for the last half of your assignment today, is find the other three pieces. Which piece should you find first?
Big B.
Why? Why is it easy? Probably one of the most famous theorems in all of geometry that you have is the fact that all angles of a triangle should add up to be 180. So what's 180 minus 90 minus 28?
62.
Yeah, that's big B. Awesome. Now, as far as finding the rest of it goes, from the 28, what is little b? Is little b opposite, adjacent, or hypotenuse to A? It's adjacent. So, which ratio do you think we should use if we're going to use the 28-degree angle that deals with adjacent? We got to find little a or we got to find little c. Those are the last two we got to find.
You could say
Huh? Okay. If I use tangent, the tangent of 28 degrees is equal to the opposite side, which is A, over the adjacent side, which is 15. So we need to now figure out what A is. We are going to cross multiply just like we did the last ones. The difference is we're going to get some decimals. Now, one thing I want you to make sure of in your calculators, for those of you who are using your TIs right now, I want you to hit mode. And in the TI calculator, the mode button is very close to the second button. Okay? When you hit mode, about the third option down, is it highlighted on radian or degree?
Radian.
It needs to be in degree mode because of the fact that we are dealing with degrees. Later on this chapter, we'll deal with radians. But for now, we need to be in degree mode. So you need to go down to where it says degree, get on top of it with your cursor, hit enter. That will then lock in degree mode. Okay? Now go second quit so that you're back out of it. Now, as far as the way that this goes, the tangent of 28, if that doesn't have a fraction, if I put that over 1, we're cross multiplying just like we did the last ones. What's 1 times A? And then on this side I have 15 times the tangent of 28, which again, here's where your calculator comes in. You type in 15 tangent of 28, and what do you get? And it says to round to the nearest. No, it doesn't. Let's go 10th. So what was it to the nearest 10th? 7.98, so 8. If it's 7.98, this has to bump that up. So it'll be 8, approximately 8. Good. So you just found little a. Now, here's what I would not suggest that you do. Was 8 an exact number?
Nope.
No, it was not. So therefore, since it was rounded, I would not use the Pythagorean theorem for this one. If it wasn't rounded, like if you did that and it came out as a whole number, then great. Use the Pythagorean theorem if you really want to. However, since it was a rounded answer, I'd rather do the trig ratios. That gets it quicker anyway. So now, c. Little c is what value? The adjacent, opposite, or hypotenuse. So if I still use the 28, and I'm going to use the 15, why didn't I want to use the 8 that you just found?
Because it's not like
It's rounded. Right, it's not accurate. So therefore, which one deals with adjacent and hypotenuse? Cosine. So the cosine of 28 equals 15 over c. And now I put that over 1 and I start over, cross multiply, do whatever I need to do. What's c times the cosine of 28? Cosine of 28c. And what's 1 times 15? 15. Now how do you find c? Divide by the cosine of 28. Divide by the cosine of 28. And now on your calculator, you're going to type in 15 divided by the cosine of 28. And how much did you get? About 17? Awesome. Now, here's what I want to keep this in mind for you also. A little bit about number sense. Is the smallest side across from the smallest angle? What's the smallest side? Little a, right? That was 8. Is that across from the smallest angle? Which was also a? Yeah. Is the hypotenuse along the side? That's the one that's across from the 90-degree corner, so you did it right. This is the last half of your assignment. You're going to have to find all the missing pieces. Would you like to do another one?
No.
I would use sine, cosine, or tangent. Stay away from secant, cosecant, cotangent, because you don't have those buttons. Okay? You have sine, cosine, and tangent buttons. You do not have cosecant, secant, cotangent buttons. Would you like me to do another one? Are you sure? Okay. That sounds so enthused. Yeah. If you go across the triangle, it's opposite. If you take a turn, that's adjacent. So if you go like this, if I go across it, that's opposite. If I take a sharp turn, that's adjacent.
It's always from the angle?
Yes.
Okay.
And then this one is always the hypotenuse because it's across from the 90-degree corner. Okay. All right. So on page 467, we got 22 to 26 evens and 33 to 43 odd.